Yeah, good afternoon, everyone. In my last lecture, I mentioned to you about how to build a stack and make it generic. So let's quickly see another implementation of the same where I allocate memory dynamically. So I have a class stack here. Is my screen visible?
Yes, sir.
Okay. So first thing is I have to create a pointer and use top as an index into the array, but in the constructor I have to allocate memory for the array A. So I would do like this, the constructor, and top is initialized to -1, and within this you can allocate space for A. So T star malloc size of. Now another problem is how do you fix the size of the stack. One is use this constant max size, otherwise use a constructor with parameter size and use it to initialize the data like that. So t star malloc size of, yeah, size of t should be. So this is the stack initialization part, and then now if you want to implement push operation, then it should be push tx. So here you're going to check if top equal to max size -1. You're going to report that stack is full. Else you will push that element into the array. So the way to do that is a of plus plus top equals x. This is push operation, right? And if you want to implement pop operation, pop would return a value, so it's generic. Then here you're going to check if top equal to -1. You're going to see out stack is full. Sorry, stack is empty. Stack empty. And since it has to return something, I will just return -1, indicating that there is nothing on the stack. So it should be in a block. So in the else part, you can return your a of top minus minus. So just observe you have to do post decrement. And if you want to display the elements, void display, you can use a for loop for int I equal to top, I greater than equal to 0, I minus minus. So you should go in the reverse order, and if you are at the top you want to display some string also. If I is equal to top, then cout a of I with an arrow here, and in the else part you're going to display just like that, cout a of I, the space, or just slash n will do, because we want to display all the elements vertically. So this is the generic implementation of stack. Okay, so here you create a stack, mention what type of data you want to push. Let's say I want to push double data type and call it as s1. So s1 dot push some value 11.2, then s1 dot push 19.8, something like this, and you can have a couple of them. So if you enter integers, it will be converted into double, and accordingly the data will be pushed. And if I say s1 dot display, it should show all the elements. Okay. As you can see, the 7 is on the top, then all the elements below that. Similarly, if you want to have a stack with string and other things, you can always do that. Just change double to string or int or whatever. Okay, so we can implement stack very easily and make it generic also, so that you can push data of any type. What are the important applications of stack? So one important application, which is very preliminary, just if you want to reverse a string, you can push all the characters of a string on the stack and then display them, so you'll get the data in the reverse order. So let's see how we can do that. If I say stack char s1, and let me take some string, let us say name Ajay Kumar, something like this. And what you have to do is you have to set up a for loop char c name. So each character you just have to push onto stack. So s1 dot push c, and just display like this. Alright, so only thing is we don't require this extra string here, and you want to display all in single line, you can remove the other decorations there. Now if I run the program, I should get the name reversed. Okay, Ajay Kumar, like this. Okay. So very simply you can implement reversing a sentence or a string using stack. Now, is this the only application of stack? Definitely not. There are many more. So there are two important applications we can think of. First important serious application is expression conversion, and second one is expression evaluation. We all know that we have arithmetic expressions, right? For example, you have a plus b star c, and if a equal to 5, b equal to 6, and c equal to, let us say, 3, then what would the result of this expression, right? So logically the multiplication should happen first. That is how the operator precedences are defined. Multiplication has higher precedence compared to addition. So 6 into 3 must happen first, that is 18, then plus 5, so 23 should be the answer. So can a computer understand this kind of expression and give me the correct result? Alright, so that is to get this expression correctly evaluated, we require a program which can convert this into what is called as postfix expression. So what we have is infix expression. You are given an infix expression. Infix means the operators will appear in between the operands, A, B, C are operands and plus and multiplication are operators. As you can see, the operators are in between the operands. Now how do I convert this into a postfix expression? In postfix, the operators appear after the operands, but you cannot just simplistically put all of them after this. So there should be a definite way of doing this. So what can be done is we can put this expression in the form of parenthesized expression. So what exactly we want to evaluate is this: a plus b star c. The innermost brackets indicate what is the precedence of operator. So b star c should happen first and plus should happen later. Now to convert this infix into postfix, what you have to do is you have to scan this expression from left to right and remove all the opening parentheses like this, and traverse from left to right here also, and replace the closing parenthesis with the most recent operator. That is, you have star as the most recent, that should come in place of this. And again there is a closing, the most recent which is not at process is plus, so plus should come here. So you get a postfix expression of a plus b c star plus. Sorry, this plus must go. So abc star plus is the postfix expression. So given this expression, I can easily evaluate this expression correctly, and using stack it can be done very easily. So let's see how I can do expression evaluation. So expression evaluation requires postfix as input, and it will give you the result of evaluating that expression. In fact, I will not be giving the expression as a plus b star c. I will be giving it as 5 6 3 star plus. So in my program I should have one string, let me call it as postfix, equal to, I will be having first operand as 5, then space. I am using space because I have to split this and extract it individual tokens of this expression. So then we have b which is 6, then we have c which is 3, then we have a star, and then we have a plus. So this is my postfix expression. Given this and given a stack, okay, so how I can implement this expression evaluation? Now for this we should have few more variables. We have to take one string token, and there is a string stream, another data type that you have to use to convert the postfix. So string stream is a class to which you pass a normal string as a argument. So this will be, it will use its constructor to initialize a string stream. So the advantage of string stream is it will treat this as a stream of digits and help you to extract each element from here. Alright, so the way to do that is you can, while ss, this is a cin operator, no, you have redirection, you take that into a token. Okay, so as long as there are enough tokens in the string stream, you process each one of them. Now once you get the token, you have to check if token of 0 is equal to Now yeah, so first thing is you have to check whether it is a operator or operand. So I have to check whether it is a digit or not. If digit, so there is a function called as isDigit. It will check whether the token which has come, whether it is digit or not. So if it is star, it is not a digit, it will go to the else part. If it is 563, it will be a digit and it will go in the if block. Now if that is the case, then you have to push it onto stack s1 dot. So let me take a different stack here, otherwise it will, let us say s2. So this will be stack char. So you just have to say s2 dot push. Okay, now one problem is we have to push these elements as decimal digits or real numbers. Okay, so we need to have a stack which is of type, let us say, double. Why I am choosing double is the data in the expression could be real or integer. So if you choose double, any kind of data will be taken up. So here I am going to push string to decimal. This is a function we have to use, and then pass this token. Okay. So what happens is your 5 will be a string. It should be converted to double data type using stod, string to double. Okay, so that will be pushed onto the stack which is of type double. Now if that is a digit, you will do that. Else, in the else part, now the logic behind what I am doing is if, just observe this expression, if 5 and 6, these are operands, right? So you go on pushing. So first 5 will be pushed, then 6 will be pushed, then 3 will be pushed. Okay, so as long as you are encountering operands, that is digits, you go on pushing them onto the stack. Okay, but once you encounter an operator, that is in the else part, you have to pop the last two, that is 6 and 3 will be popped, and whatever is the operator, depending on the operator, appropriate action has to be performed. So first thing that you do is here you take two variables, double d1, you just say pop double d2, then pop. So the last two will be popped, and once in the else part, you know, you have an operator, and this pop operation should happen on your stack. Just 2 dot pop and this 2 dot pop here. So the two values are popped, and depending on what has come, so you have to use switch token. In case if it is plus, then you have to perform the addition, right? So you have to say you can take one more variable here, double result, result equal to d1 plus d2, and break from here. And if it is minus, okay, one thing is it is a character, so it should be in single quote. Should it be token of 0 here? Yeah, token of 0. Because when you put that string into token, it will be a string. So token of 0 will get you to the first string. And here it should be d1 minus d2.
But actually, before that, we need to check for the which is greater than, or else it will be minus.
Pardon?
Uh, Actually, the thing is, if D1 and D2,
Huh.
if D2 is greater than D1, then we need to reduce it to D2 minus D1. Or else it will get a result of like.
No, that will be taken care of here. That will be taken care of here.
Okay.
Okay. So if d1 is greater than d2, you will get minus result, no?
Right, that is what.
Yeah. So that should be fine.
Okay.
And once you come out of this result, what you have got here should be again pushed onto stack.
Right. Okay.
So I'll explain the logic, but now try to understand that if you encounter operands, you just push them onto stack. And if you get an operator, then pop the last two and perform the operation and push it. And when you come out of the loop, when you come out of this loop here, while s token, yeah, here you just have to get the result, final result as s2.pop. So the result will be on the stack at the end, and you can print that. Okay. So you can say cout result equal to result. So let me remove this. In fact, I had used this earlier. This is one thing we can close for now. Okay. So what I did essentially is I took a postfix expression and processed that using a while loop. And the logic is if you encounter operands, go on pushing them on the stack. And if you get an operator, you have to pop the last two and perform the required operation. So let's see whether we get the required result. 23. So is that a result expected? Let's see. Our expression was here, right? So 6 into 3, 18 plus 5, 23. Isn't it? So this is the expression that we get. Isn't it? Yeah. Now suppose the expression were like this, a star b plus c. Then the corresponding expression would have been ab star then c plus. This is a postfix expression of a star bc. Okay, so I have to change this in place of 3 I have to put a star, and in place of star I have to place 3 and this. So now the result should be 5 into 6 30 plus 3 33. So let's see whether we get the correct result. Okay, so we are able to utilize stack to evaluate an expression which is in the postfix form. Now it is also possible to convert an infix into postfix using stack, but that program is pretty complicated. That's why I've taken a simpler one. Okay, so would you like to try this out, implementation of a
Sir, before trying in quick words, can we go through once?
Okay, so yeah, so let me first explain to you the logic behind this. I told you that we'll have a expression which
Okay.
is initially infix. Infix means the operators will be in between the operands. Let us say 7 star 5 minus 2. Okay. Then we might have plus 3 also, like this. Okay.
Okay.
So real meaning of this is these two should be done first.
Okay.
Okay. And then the result can be subtracted from 2 when you are going from left to right, and then you can add 3.
Okay.
Okay. Now how does a computer understand this? You know this is how it should be done. So for that you have to convert this into postfix. So to do this postfix conversion, there is a logic behind that. You just put the brackets around this, right? And then you want to perform this, and then you want to perform this.
Okay.
So when you scan from left to right, you eliminate all closing brackets. You get 7 first. Okay, and then if you encounter operator star, you should push it to the next closing bracket. That is after 5, this star should come.
Okay.
Okay, then you encounter -1. This should replace the next closing bracket. The 2 should be kept here, minus should come. And then again this 3 should replace this last one. So 3 should go here and then plus should come here. So this is my
Postfix.
postfix expression. Okay. Now I will use a stack to do the evaluation. So let me show you with the diagram like this. Okay. Now what I am going to do is, this is, assume that this is a stack initially empty. Your top go to -1 is here, and this is your tag. Now you have to process this postfix expression. This is what is given to us. So you start from left hand side. You encounter a digit 7, so you push it onto stack. So this is gone. Then again you encounter a operand, you push it onto stack. This is gone. You encounter an operator now. The moment you encounter an operator, pop the last 2. So your D1, when you pop, that is S2 dot pop we are doing, no?
Yeah.
So what happens is D1 will get 5, and D2, again when you pop S2 dot pop here, you will get 7 in D2. And we know the operator is star, so you have to take this last 2 and perform D1 star D2.
Okay.
So you get it as 35. Okay, and since you have popped the elements, there is nothing on the stack. Again, stack is empty, and this result what you have got, 35, should be pushed onto stack. So 35 again goes and sits here.
Okay.
Now proceed further. You go to 2. You encounter a operand now. You push it onto stack.
Okay.
You encounter a operator. Then you pop the last 2.
Okay.
This time when you pop, D1 will be 2. D2 will be
35.
35.
Yeah.
And then perform what is required by this operator, minus.
Okay.
So 2 minus 35 will happen.
Okay.
Is that right? Or 35 minus 2 should happen?
35 minus 2.
35 minus 2 should happen, no, here. And this is where we are going wrong. Yeah. So when you pop D1, yeah. So 33 is what you should get. Okay.
Correct.
You should not subtract 35 from 2. You should subtract 2 from 35. We shall see why it is happening correctly in our case. Assume that this is how it happens, and you get 33. And again now you have popped the last 2. Stack is empty again. Now you have to push this 33 onto stack. And again proceed further. You encounter 3. So 3 will go here. Correct. Again you encounter operator.
Correct.
So you pop the last 2. d1 will be 33, d2 will be 33, and again the operator expects you to add these two, so d1 plus d2, which is 36. So again, whatever result you got, stack has become empty, right? After you have popped these two, again you have to push this onto stack, 36. Since you have reached the end of the expression, you have to come out of the loop and pop whatever is there on the stack as a result. That is why we have the last pop there, isn't it?
Yeah.
So you get this result 36 as the answer. Okay. So you take any expression in fix containing division, this, that, it will correctly evaluate to the result.
This was clear, sir. Thank you.
It's clear, no?
Okay.
Okay. Yeah. So now let us see if we can implement and. So what was the result expected? In our case, I think so I took some different values here. This expression was different, so we are getting for 5, 6 star 3 plus, we are getting the correct result as 33. What happens if I put a minus? I have to see. Just that it will be 3 less, I guess. Minus 27. So this is what is happening. So what you should do is you should take this as d2 and this as d1. Then probably we should get the right answer. Yeah, that's right. Now whatever expression I chose here, 7, 5 star 2 minus 3 plus. So if I put this, let us see whether we get 36 as the answer. 7, 5 star 2. 7, 5 star 2 plus 3 minus, right?
So 2 minus 3 plus.
2 minus 3 plus. 2 minus 3 plus. Yeah. We are expecting 36 as the answer. We got 36 as the answer, right? So, would you like to try this out?
Yes.
Or I'll share the source code and you try it at home.
Will try.
You'll try it, huh? Okay. Yeah, go ahead. So just to summarize, you can implement a stack as a generic class and use it to perform operations like reversing a string or evaluating an expression, or even converting a infix to postfix is also possible. The logic is pretty involved because you have to take into account the operator precedences and all that. So you will find that in some documentation on the net, or if you have ChatGPT to give you the program, you can try it out. Okay. So application of stack, there are many, but I've just given you a glimpse of how stack could be used in 2 different scenarios. All right. We'll begin with queue data structure in our coming lecture on Friday. All right. Okay, then we'll stop here.